Hello guys, welcome to this tutorial series on algorithms and data structure. So today we are going to be looking at how to create a polynomial representation using a linked list. So we are going to basically be having a series of tutorials on how to actually implement all of the different functions of the polynomial using a linked list. So this is basically going to be used with the C programming language, or for those of you who can use C++, it is quite good for you. So I am Nebota Ismail and I'll be taking you through this video tutorial. Now let's look at now polynomials. Polynomials are mathematical expressions that consist of algebraic terms involving coefficients, exponents, and variables. So they find extensive application in various fields of mathematics and science. Polynomials can be manipulated using operations such as addition, subtraction, multiplication, and evaluation. Now those are just few of its many operations. So today we are going to be looking at the basic operations like creating a polynomial, to display them, how to add them. So we are going to be having a series, so stay updated with this. I encourage you to subscribe so that you can actually follow up with everything we are doing chronologically. Now, to represent a polynomial in C, we propose a data structure called polynode. So what that means is, since we are dealing with data structures, we are going to be creating our own data structure. We are going to call it polynode. Now this structure is going to encapsulate a single term of the polynomial and includes following members. So now the members are going to include, we have a coefficient, is going to have an exponent, so it's also going to have the next is a pointer to the next term. Now that is basically one of the major operations of a linked list. That's why we are going to be using a linked list. So now what's a linked list? A linked list is a common data structure consisting of a sequence of nodes where each node contains a value and a pointer which is a reference to the next node in the sequence. Now the last node typically has a null pointer as its reference. Next, now what does this actually mean? Provided a polynomial, let's say we all know the structure of a polynomial. We have basic polynomials like quadratic equations. So basically we see that we have a sequence of functions. So let's say we have 2x cubed plus 2x squared plus whatever it is. So basically when we are looking at this structure, we basically see that the polynomial has continuous terms. So why do we need a linked list to implement what we are doing? It's because the polynomial, the linked list, is actually going to now map the different terms together. So we have the first term which now holds address to the next term, so basically creating it in that list form. So we are going to be seeing how this is implemented specifically. So let's first of all see how we can implement the structure. Let's see how we can implement the structure in C. So I'm going to be using dev C++ for my programming. So let's look at now. If you are working with C, I'll first of all advise you to, before you want to begin, I'll save my project. I'm going to first of all start or define hash include stdio.h. so this is the standard library. I think most of you know that. Now I also include this stdlib.h. these are for other operation. Std hash include, I have stdlib.h. So those two are going to be there now. So I'll first of all define my data structure for our polynomial, which is going to be the polynode. So how do we do this? I'm going to have the type definition struct. I'm going to call it polynode. Yes, polynode. So now, okay, not so. Okay, so it's going to be like this. So now this structure has three attributes. First of all, we have a coefficient which is an integer. So in coefficient, we are going to call it like this, coefficient. It has an exponent. So and it also now has it has a pointer to the next term of the polynomial. So how do we do this? So we are going to be using struct. So struct polynode. So make sure that the term is the same, or else you are going to run into an error. It has a pointer to it, so I'm going to use an asterisk, then next. So it holds there, address to the next term. Now that's what makes it a linked list. So we are going to give it a standard name here called poly. So I do not want to go about every time we want a polynode and start calling struct type def everywhere. So we are going to call it poly. So we know whenever we reference poly, we are actually talking about the data structure we have created. Okay, so that's the basic definition now of our polynomial. So that's going to be the data structure we are going to be using. So here I'm going to have a list of questions that we are going to be answering. So I have a list of questions we are going to be answering. So I've succeeded to define a polynomial. Now let's take a look again at now what we have. Now the create poly function is responsible for creating a new node for the polynomial. Now please let's take a look at something. We have a polynomial. Now we know that every polynomial by default it has a coefficient. For example, let's say if you have 6x cubed, 6 is a coefficient, 3, which is the exponent, also corresponds to, these are the different components that make up the polynomial. So that's why if we are defining this structure, we must have a coefficient, we must have an exponent, because all of the different terms have these different parameters, if I may say so, or perhaps I say attributes. Now let's look. The create poly function is responsible for creating a new node for the polynomial. It takes a polynomial pointer, which is polynode star p. So we are going to be defining a polynomial pointer, which is called polynode star p. So the name is p, we have a coefficient, we have an exponent as parameters. So the function performs the following steps: allocate memory for a new polynode structure, assign the provided coefficient and exponent values to the new node, append the new node to the end of the polynomial linked list, or makes it the head node if the polynomial is empty, updates the next pointer of the previous node to link it with the new node. So here's the source code. Now I'm going to make this as simple as possible so that we all can understand. Now let's get into the phase of programming, right? So let's say we want to create the poly function. Now since we are going to be using a void, so void create poly. So void create poly. Now in order for you to create a polynomial first, now remember the create poly function is to create a new node for the polynomial. So what that means is we can either be using an existing polynomial, or we are creating a new polynomial which has no node. So it is either the polynomial already has several nodes, or it has no node at all. So now what do we do? First of all, we are going to be needing a pointer to the polynomial that we are going to be using. So what that means is we are going to be using an address, the address of the polynomial. So how do we do it? Now in order to declare our polynomial, right, in order to declare that this is a polynomial we are going to be using, we are going to use the poly call. So I'll say poly star p. So what that means is the poly here, this poly refers to this data structure that we have created. So it means that this is a poly that we are actually defining here. So the poly, which is a data structure star p, if in case it exists, so it could either be that this exists or not. So this can be either null. So let's say if you want to create a polynomial, we have multiple terms. So it can either be that the polynomial already has several terms and we are adding a new term to it, or it has no term and we are struggling to create the first one. So firstly, we are going to need the pointer to the polynomial itself. Now we are going to need the coefficient. So in coefficient, int exponent. So those are the two parameters, those are the three parameters that we are going to need to append a new node to our polynomial linked list. Now in order to begin, we are going to follow exactly what was said. Firstly, it said allocate memory for a new polynode structure. Now, how do we do this? So if in case we have we need to have a new node created, right? Firstly, we need to allocate memory to store these polynomial values and everything. So how do we do this? We need to allocate memory. How do we allocate memory? We are going to be using the malloc. So we are going to have poly. Remember, we are not using struct polynode again. No, the reason is because we have already defined poly here to reference struct polynode. So this is a name. So whenever you give it and you give it this extra name, I mean this is what you are going to be using to reference your data structure. So I'm going to say poly. So this is going to, since it's a pointer, poly star, I'm going to call it new node. So poly star new node should be equal to, we are going to give it the size of poly. So poly star malloc, which is holding the size of poly. Okay, so what have we done? We have allocated memory now using the malloc function. So using the malloc function, since we are creating a poly structure, this is here to define the kind of memory that we need, since the poly has already been defined here. So the pointer to the poly is being created. Now the malloc function locates memory of this size, the size of the poly, right? So it means that this memory location, now new node, has this address. So this is a pointer to our new node. Now how do we actually append values to the new node? So what that means is we have already created memory space to store our new node, right? Now let's actually create setting. Let's add now, let's say, data to the new node we have created. Now new node, remember, new node now is still a poly node because it's a poly node. So what that means is it has access to all of the different components that make up our data structure, our poly node. So I'll say new node. So we are going to set the new node coefficient to point to be equal to the coefficient that you have inputted. So you see, so we are going now to set the new node coefficient to be the coefficient that the user is going to input in. So let's see if it is 2, it is 3, depending on what you want, depending on the sort of node you want to create. Now the exponent. So we are going to say new node. We have this. Remember, this particular arrow here is pointing towards the various properties that make up this our data structure, this our polynode structure. That's why we have these arrows. So these arrows are there to actually signal what specific property, what specific attribute of your structure you are talking about. So if you put new node a pointer to coefficient, it means that we're actually referencing the coefficient. So new node exponent should be equal to the exponent that the user puts in. Now we are going to append now the new node next. So we are saying that the address to the or let's say the next term, we are appending it to 0. So the new node, remember, a linked list, we are using a polynomial. A linked list stores the address to the next node, right? So since the next node here, we are creating a new node, we append the next node to null. So I'll say new node. Next should be equal to null. So we are going to append it to null. What that means is going to be void. There's going to be no data there. So now what we have done is we have actually created a new polynode structure. But now there's going to be a problem. How do we now add it up? How do we now actually create it such that whenever a new node is being added, or let's say, for example, let's say a node already exists, right? How does it append? How do we do all of this? That's what we are going to now have to do a little bit of work, but it's not difficult. Now let's look at it. So let's look at the next statement. It says append the new node to the end of the polynomial linked list or make it the head if the polynomial is empty. Now what we are saying is we have created a new node, right, and we have assigned the coefficient and the exponent. So let's say if we wanted to create 6x cubed, we have actually created that node. Now we need to now either append this new node to the end of the polynomial. What that means is, if in case it's already a polynomial that exists, that already has terms, we are going to take the new node we have actually created and we append it to the end. Or if in case the polynomial is empty, we are adding now the new node as the head of it. So let's see how this is going to work. So now if the data to our polynomial, if star p here is equal to null, that means the polynomial structure that has been imputed is null, so that it does not actually have any data. If star p, remember this star p here, it now says that this is the data now stored in the polynomial. If it is null, so we are going to now append now the new node to node. So what that means is we are going to say that star p should be equal to new node. So what have we done? If the polynomial that actually has been put here has no data, what we are doing is since it's going to be now, what we are going to be doing now is going to be the first node, right? We're actually creating the polynomial. So we are just now initializing now this particular polynomial to the new node we have just created. Yes, so that's how we do it. This is if in case the polynomial does not exist. So this is actually the first point of the polynomial. So if star p is equal to null, so if the data of this particular polynomial is null, we set it to new node. Now else, we have an else statement. Now, so remember what was said. So if in case it is the first node, it creates it, else it's going to now append it to the end. So let's say the polynomial structure already exists, you now add it to the end. So how do we ensure this? We are going to now work by, we are going to create something. So I'm going to call poly star, I'm going to call it current. So we are going to create this new polynomial called current, and we set it to star p. So what are we doing actually now? So we are creating a new node, right? Remember this is the polynode structure. We are creating a new node called current, and we save the value of the actual polynomial which came here, the node which came here, right, of the polynomial structure, which came here. We append it to the current. Now what do we do next? While we are going to be using a loop here. So while current next is not equal to null. Now what does this statement mean? We have actually now given the polynomial structure which was initially passed with our create poly function to this structure called poly. So now what are we doing? We are checking. Normally we know that every polynomial, right, every node holds the address to the next node. That's if it exists. So perhaps we say we have something like 2x cubed plus 2x squared. We know normally that the 2x cubed hold address to the next one. So what we are saying is that if we are going to initialize current with the actual polynomial which was given, now while current next is not equal to null, so it means that it's going to start iterating. It's going to start iterating from the first term. while the first is going to check the first term, is going to check the next. Is it equal to null? It performs whatever is going to be performing until it increments to such the point that it is equal to null. Remember, if it is equal to null, it means we are at the end of the polynomial. So while current next is not equal to null, what happens? Current is equal to current next. So what are we doing? What are we doing? We want to get to the end of the polynode structure so that we can now append the new node we want to create, right? Remember, we want to create a new node, so we must get to the end. So we are saying that while the current next is not equal to null, that means then for every node that we are in for this particular polynomial star p, for this particular polynomial, if the next node is not equal to null, it should keep on incrementing the current. The current now should hold now instead the data of the next node. So when it increments this one now becomes the current, and the current still checks this. Is the current next still equal to null? If it is not, increments again until the point where it's going to get to the last node, where the next now is going to be null. It's going to break out from this loop. So when it breaks out from this loop now, it's going to set current next. It's going to set current next. It's going to set current next to the new node. So what have we done? What have we done now? So actually what we have done is we have iterated to the end of our polynode structure, right? Of our polynomial structure, and appended the new node. So that's the reason why we have this particular while function here. So while current next is not equal to null, this is equal to this. So when it gets to the point where it is equal to null, we know that that's the last term. So now we now say that the current that we are going to have, what we are going to end up with now, we now append the next node to it now to be equal to this. So we have actually now added a new node. We have actually created a new node. Remember, a new node has its coefficient, it has its exponent. So that's how actually we can work this. So immediately that is done, we have actually, this is how we create a new node now for the polynomial. So whenever we call our polynode structure create poly, if we call create poly, what we are doing is we are going to be passing in our pointer to our polynomial. We are going to be giving it a coefficient and an exponent. That's if whenever we are to create a new node. So I hope that is quite understood. Please, in case you face difficulties understanding, try to leave a comment so that I can get back to you immediately after this. Okay, now, so what we have done is we have created a function now that can actually implement a new node for the polynomial. So I'm going to write something here so that we can test what we have actually done. So I'm going to create an int main function. Int main, this is just to test. It's not going to be holding so much data. Int main, I'm going to return 0. So return 0. So now I'm going to set it if star p is equal to null. So I'm going to here say printf new, okay, let's say poly, this is first node. So I'm going to say this is first node, or I'm going to say, okay, at the end of this is new node. Okay, so I'm going to now call our create poly function. I'm going to call our create poly so if I want to call the create poly, I first want it to append a new poly. So I'm going to say poly, so I'm going to say poly, I can just call it poly1 should be equal to null. So this is because I want to just test. So we are creating a new polynomial structure, so I'll call it this. So create poly. Now I'm going to pass, I'm going to pass in our poly. So the poly now here should be equal to poly1. poly 1, comma, the coefficient should be 6, comma, the exponent should be 2. So that's supposed to be 6 something to the power 2. So okay, I'm going to have this and I'm going to print. So let me run this program and actually say, okay, it's time to save. So I'll say polynomial linked list. Okay, so this is C file. So okay, that's it. Let me see now. Okay, so I hope this is the program. The program has run successfully. I don't know why it has not printed. Okay, let me see what is happening. It's a passing argument 1 of create poly from incompatible pointer type. Okay, from incompatible pointer type. Okay, let me understand what's happening. Okay, it's okay. I think the problem is because of where I put this printf, so they are not actually at the right position. Yeah, but I've done a little bit of debugging there. Return value this is because of the position of the printf function, but it's okay. So this is how we get the create poly function. That's how we get the create poly function. Okay, I just realized something too. Okay, you need to remove this, and here where you have this poly 1, right? This is the problem. Now where we have this poly 1, remove poly 1 from here and add an and, so that we are pointing to editor. So yes, so you need to put it like this, and let's see it. Yes, this is the first node, this is the new node, so it's going to now actually print us what we want. Yes, so that is it. So yeah, this is the first node, so that was because that's the first node. So let's see if we create another node again. If we create another poly, taking this same node and poly 1, we have here 8 3. So let's see, this is the first node, this is a new node. So you see, it's because the first one is the first node there and the next one is a new node. So that's how we can keep on now creating multiple node structures. Okay, now that is just for the create poly. Now we are also going to look at for the display poly. So let's see how we can display poly. Degree of poly 2 is there. Okay, now to display a poly node simply means, okay, we want to display the polynomial, right? So to display poly function is used to display the polynomial. It takes in the polynomial pointer. Now the function follows the steps to check if the polynomial is empty. If so, it displays the corresponding message. It iterates through the polynomial linked list and prints each term in the desired format. Includes appropriate formatting and symbols. Okay, now let's look at that. So we are going to be creating a new function. So void, that is to be display poly. We are going to use it display poly. So it takes in poly. It takes in pointer to the poly node. So yes, to the polynomial. So we are going to use that. Now, since okay, we have declared this, now we need to display it. What did the first thing say? Check if the polynomial is empty. If so, it displays the corresponding message. So we are going to check if p is equal to null. So that means that's the comparison. So if it's equal to null, we are going to print a message. I don't want to write too much. We are going to print a message. This is null, so this is empty. So empty. Yeah, that's good. So if it's that, then we print it's empty, and we break out from the statement. So we are going to return from here. So basically, so if it is empty, there's no need to continue any other thing, so we just break out from there. Now we are going to also have now what happened in case it is not empty. So you can use this as an else, or you can just leave it. As long as this one is here, every other thing performed here is going to be let's see, it's just going to be considered. So what we mean by that is, if in case it is null, right, it's going to break off, or if it's not equal to null, it's going to follow this other pattern. Now since we want now to iterate, we want to now print all of the different terms of the polynode. Now we know that the polynomial actually could have many terms, right? So we are saying that if the polynomial inputted is equal to null, that means no term is there. There's no term to the polynomial. We simply break off from there, we return. Now if in case it has nodes, if in case it has terms, what do we do? While we are going to use a while function again, while the polynomial is not equal to null. So while our poly is not equal to null, so this could be a node. Remember, it is starting from the beginning. We want to iterate through all the different terms. So while our node is not equal to null, we are going to start, we are going to print f. We are going to print f. So we are going to say percentage d to the power, where is to the power, yes, to the power percentage d. So we are going to print this. So let's say, for example, this is the first one now is going to hold the coefficient, and the next one is going to hold the exponent. So we are going to use it. So the first one is supposed to be coefficient, so we are going to have p coefficient. The next one is going to have p exponent. So that's it. So now while p is not equal to null, it should do this for the first time. So after it does this the first time, what happens? We now set p should be equal to p next. So what that means is now it's going to now the value for p now is going to hold now the pointer to the next polynode. So that means now it's going to now increment. So it goes now to the next polynode if it is not equal to null. So provided that now this thing shows that p is equals to p next, if the value is null, it's going to break off from this statement. So remember, this is the case only if that particular term, the particular node is not equal to null. Provided it is null, it breaks off. If it is not null, it continues. It's going to continue the iteration. So now p is equal to p next, right? Now again, there's another little statement. If p is not equal to null, we are going to print a plus sign, print f. So we are going to print a plus sign here. No. So what's this plus sign here supposed to do? What's the plus sign here supposed to do? Now, while p is not equal to null, we are starting. So let's say we are starting from the first term. It should print percentage d, percentage d. So it should print the coefficient and the exponent in this way, right? Now p should equal to p next. So actually now the value of p now becomes the pointer to the next node, right? Now it checks, is the next node equal to null? If it is not equal to null, it prints a plus. So that means we are now adding the nodes. So it's just like 2x squared plus 2x. So that's how it's doing it. So if it's equal to null, it does not add a plus sign, but if it's not equal to null, it adds a plus sign there. Now once it adds a plus sign, now it comes back again to the loop. Is p equal to null? If it's equal to null, it breaks. If it's not equal to null, it prints the next term again, exactly like that. So that's how it functions. So that's it. So that's it from here. We just need to print a new line. Yes, we just need to print f, print a new line so that it should break. So that's it. We have displayed our poly. So now let me display poly now. Let me display our polynomial, what we have created. So I'll say display poly. I'm going to pass in p should be, it should hold, and it should hold the address, the value of that. So what is it? So and poly 1. Yes, good. What's happening? Okay, let me see. Okay, this was a little problem. Okay, now let me try to rerun it. Okay, this is it. So you can see 6 to the power. Oh, we have done a little mistake. I did not put x. So percentage d x to the power that. So let me see again. Okay, so you can see that we have 6x squared plus 8x cubed. So what we have done is we have displayed the polynomial we have actually created. So if we can create a new note again, let's create a new note again and see what happens. So now I'm going to give it to the power 4. I'm going to give this to be 16. Yes, so I'm going to run it again. So you now see 6x squared plus 8x cubed plus 16x to the power 4. That is interesting. So that's how we are creating our polynomial. Okay, so now let's look at the degree. Now we want to check the degree of the polynomial. Right? So let's check the degree of the polynomial. Now the degree poly function calculates and returns the degree of the polynomial. It takes in the polynomial pointer, yes, as parameter. The function performs the following: initializes a variable max degree to 0 to store the maximum degree encountered. So first of all, it considers the maximum degree to a certain value, to 0, which is what we initially give. It iterates to the entire polynomial linked list, checking at the exponent. If the exponent is higher than actually the max value which we have initialized, it now says now the max degree here is equal to exponent. So let's take a look at the code and see what it's actually talking about. So firstly, we are going to start with, so since it's an integer, we are going to start with an integer. So see, we have int degree, or just call it like this. So it's supposed to take in simply our poly. So we have our poly star p. So poly star p now. So we are going to say int in degree, we are going to initialize it to equal to -1. We are going to initialize it to equal to -1. So while now we want to iterate through our polynomial structure, right? So while we still do the same, please do not forget this particular step. While p, which is our node, which is the current node that we are there, is not equal to null, so we are starting from the beginning. While p is not equal to null, now we check if p exponent is greater than the degree we have just passed. If p exponent is greater than the degree, what is going to happen? We are going to now set the degree to be equal to p exponent, right? Yes, so we simply do that. After doing this, we now increment p. So p now should be equal to p next. So I hope this one has met you very well. So since we have constantly repeated it again, I hope by now you must have understood. So we are going to return now degree. Let's see. Okay, we have not closed it here. Okay, so that's it. So now let's say maximum degree. So now we are going to say int max degree should be equal to degree. We have our poly structure, we are going to give it and poly1, right? So now let's print f percentage d is max exponent, so now what is percentage d? It should be equal to max degree. Okay. I noticed that the degree here, this particular degree and this one also correspond here, which could be a problem. So I'll call this max degree, so it should return max degree, right? It should return max degree. What is this? No, it should be like this. While degree, okay, while max degree, we have changed this max degree, yes. Okay, let's see comparison between pointer and integer when in comparison in main function. So let's look at, okay, I'll just go ahead quickly and debug that and help us with the final code so that we don't have to waste so much time. Okay.